Hello students, welcome to the course in operating system. Myself Rafiqul Islam, Assistant Professor, Department of Computer Science and Engineering, Guru Nanak Institute of Technology under JIS Group. In this lecture, we are going to discuss about priority scheduling algorithm. And in previous lecture, that is in lecture 12, we have discussed about shortest remaining time first algorithm. And we have solved 3 numerical problems on that algorithm. Okay, and we have seen that in SRTF algorithm, we have starvation problem exist. So now in this lecture, our topic is priority scheduling algorithm. Okay, so priority algorithm. Actually, before starting the actual algorithm, first see what is priority. What is priority? Actually, a priority is associated with each process. Each process, and it is basically a number. It is basically a number. Okay, and two processes can have same priority. So basically it is not the process ID. So please clear it. It is not the process ID. Process ID actually unique number, but priority is not unique. 2 or more processes can have same priority. Okay, and highest priority process gets the CPU first. Highest priority process gets the CPU first. Okay, so this is actually priority. Now actually this priority either static or dynamic. This priority either static or dynamic. So in case of static priority, the value does not change throughout the execution of the process. Does not change throughout the execution of the process. That's why it is called static. But in case of dynamic, changes at regular interval of time. Here, changes at a particular interval. Okay, so that's why it is called dynamic. Dynamically changing the priority, and here it is fixed. And basically in our lecture we are considering only static priority. Okay, so in our problem the given priority actually static, and which one is highest priority? Actually some systems use low number to represent low priority. So some system use low number as low priority, and some system assume high number as low priority. Okay, so some system use low number, low priority, and some use a high number to present low priority. Okay, so it is depends on the system design. And in this our next problem we assume low number as high priority, right? Low number as high priority. And if two processes having same priority, then to break the tie we use arrival time. And if arrival time is also same, then we use process number to break the tie. So already we know that two or more processes can have same priority. So if two or more processes having same priority, so to break the tie we have to use the arrival time. And if arrival time is also same, then to break the tie we have to use the process number. Process number actually unique for every process. Okay, and now so in this particular algorithm, in this particular priority algorithm, criteria of this algorithm actually priority. Every time we have to check the priority for each process. The process having highest priority, we have to choose that process from ready queue and put it into CPU for execution. Okay, so here the criteria is priority. And now mode of this algorithm, actually priority scheduling can be either non-preemptive, so it may be non-preemptive, and as well as can be preemptive also. Okay, so priority scheduling algorithm either non-preemptive or preemptive. So in this particular algorithm we have to solve a numerical on non-preemptive and another numerical on preemptive. Okay, so these are the basic points on priority scheduling algorithm. I hope these points are very much clear to you. Okay, now see the non-preemptive priority algorithm. So this is our first mode of priority algorithm, non-preemptive priority algo. So here criteria obviously priority and the mode is non-preemptive. So here once a process is assigned in CPU, we can't forcefully remove it from CPU until it finishes. Okay, we know in case of non-preemptive algorithm, we can't forcefully remove a process from CPU in the middle of its execution. So after completion of the process, it can remove, it can terminate it. Okay, but in the middle of the execution, we can't forcefully remove it from CPU. So this is actually non-preemptive algorithm. So now here we have to solve a problem. So here given process number and obviously given priority for each process. Next given arrival time and obviously given burst time. Okay, so this is given data in your numerical problem. And suppose here we have process P1, P2, P3 and P4 and priority given 2, 1, 4, 3 and here we assume lowest number as highest priority. So it is actually highest priority 1. Here arrival time given 0, 1, 2, 3. Burst time given 4, 3, 2, 5 suppose. Okay, so this is the given data. So now using the non-preemptive priority algorithm, we have to calculate here the average turnaround time, average waiting time and average response time. So here we have to calculate average, here we have to calculate average turnaround time, average waiting time and response time and throughput of the system and system throughput. Okay, so these parameters we have to calculate here. So now see, we know in order to calculate these parameters, first we have to draw a schedule chart or Gantt chart, right? So the Gantt chart basically, suppose this is our Gantt chart, and obviously this chart always starting from 0. So now check which one is highest priority process, that is P2. But at the same time we have to check arrival time also. Okay, so when time 0, then in ready queue we have only one process, that is P1, and when time 0, then P2, P3 and P4, they are not present in ready queue. So as only one process, that is P1, is present in ready queue, so obviously we have to schedule P1. Okay, so we have to schedule P1, and as this algorithm actually non-preemptive mode, so obviously we have to assign P1 for 4 time unit. So P1 completed and terminated. Now when time unit 4, then in ready queue we have P2, P3 and P4, because the arrival time of P2 is 1, arrival time of P2 is 2, and P3 is 2, arrival time of P4 is 3. So when time is 4, then in ready queue we have 3 processes, that is P2, P3 and P4. Now check among P2, P3 and P4, which one is highest priority process. So here the priority of P2 is 1, so it is actually highest. So next we have to schedule P2, and the burst time of P2 is 3, so the time bound here should be 4 plus 3, that is 7. So now P2 completed. Now next we have in ready queue P3 and P4, and here the next highest priority, that is 3 for P4. So obviously we have to assign next P4, and as the burst time of P4 is 5, so we have to assign it for 5 time unit. So the next time bound should be 7 plus 5, that is 12. So P4 terminated. Now after that we have only one process in ready queue, that is P3. So we have to assign P3 next, and here the burst time of P3 is 2. So the next time bound should be 12 plus 2, that is 14. So this is our schedule chart or Gantt chart. Now using this chart we can calculate, number 1 starting time, number 2 finished time, number 3 turn around time, number 4 waiting time, number 5 response time. So now see, for P1 starting time 0, for P2 starting time 4, for P3 starting time 12, for P4 starting time 7. So starting time, we can write starting time direct from the chart. Okay, so now for finished time, so also we can write finished time direct from the chart. So finished time for P1, that is 4. This is the finished time for P1, that is 4. Finished time for P2, this is 7. finished time for P3, that is 14. Finished time for P4, that is 12. Okay, so this is the finished time. Now calculate turnaround time, and in case of turnaround time, we know the formula. Turnaround time nothing but finish time minus arrival time. Turnaround time actually finish time minus arrival time. So for P1, finished time 4, arrival time 0. So turnaround time obviously 4 minus 0. For P2, finish time 7, arrival time 1. So it is 7 minus 1, that is 6. In case of P3, finish time 14, arrival time 2. So turnaround time 14 minus 2, that is 12. And in case of P4, it is 12 minus 3, that is 9. And here the average value should be 12 plus 9 plus 6 plus 4, that is 31 by 4. So this is the average turnaround time. Now for waiting time, we know waiting time actually we have two formula. Waiting time actually starting time minus arrival time, or turnaround time minus bus time. You can use any one. Okay, so waiting time, if we consider turnaround time minus bus time, so 4 minus 4, that is 0, 6 minus 3, that is 3, 12 minus 2, that is 10, 9 minus 5, that is 4. So this is the waiting time. Okay, so average waiting time, that is 17, average waiting time 17 by 4. And response time, we know the response time actually fast response minus arrival time. And also we know that in case of non-preemptive algorithm, the response time and waiting time always be equal. So here waiting time 3, so response time also 3, 0, 3, 10, 4. So average obviously 17 by 4. Okay, and throughput, here throughput, we know that throughput is equal to number of processes executed by the CPU per unit time. So here total number of process 4 and total time taken 14. So throughput of this system actually 4 by 14. Throughput actually 4 by 14. Okay, so this is actually non-preemptive priority scheduling algorithm. So here, in order to draw the Gantt chart, we have to check the priority, and at the same time we have to check the arrival time also. Okay, so this is all about non-preemptive priority algorithm. So I think this numerical is very much clear to you. Okay, now see the next mode of this priority scheduling algorithm, that is preemptive mode. So our next mode of this algorithm, this is second mode, and this is preemptive algo. So in this case, we have to check the priority and arrival time, and we have to switch we can switch a process from its middle of its execution. Okay, so this is the concept of preemptive. So now see an example. So suppose here given process, so this is our process number, this is given priority, this is arrival time, and this is burst time. So here given process P1, P2, P3. Arrival time given 0, 2, 0, 2, 3. Burst time given 5, 6, 3. Priority given 3, 1, 2. Okay, and obviously this is the highest priority, smallest number considering highest priority. Okay, so these are the given data. Now draw the schedule chart first. So here the schedule chart should be like this. This is 0. Always start from 0. Now check priority. So actually here the highest priority process actually P2, but when time 0, P2 is not present in ready queue. So when time 0, only P1 is present in ready queue. So obviously we have to put P1. And we have to put P1 for time unit 2. Why? Because the next arrival time actually 2. So we have to put P1 for time unit 2, and again we have to check, right? So here the remaining time for P1 is actually 3. Now when time is 2, then in ready queue we have 2 processes, that is P1 and P2. And between P1 and P2, the highest priority process actually P2, because the priority of P2 is 1 and priority of P1 is 3. So now we have to select P2 for execution. Okay, so here we have to put P2 for time unit 6. So it will be 6 plus 2, that is 8. And at the same time, P2 completed. Now this moment in ready queue, we have 2 processes, that is P1 with priority 3 and P3 with priority 2. So obviously P3 actually highest priority process. So now next we have to schedule P3. So we have to schedule P3 now. So the burst time of P3 is 3. So we have to schedule it for 3 unit. So 8 plus 3, that is 11. So P3 completed. Now after that we have to schedule P1, that is 11 plus 3, that is 14. So this is our schedule chart, Gantt chart. Okay, so you can see here P1 actually, here P1 actually preempting process, right? It entered in CPU twice, one here and another here, right? So this is actually preemptive priority algorithm. Okay, now using this we can delete this part. Using this chart we can calculate the starting time, finish time, turnaround time, waiting time and response time. So we can calculate here starting time, here finished time, here turnaround time, here waiting time and here response time. So starting time for P1, this is 0. Starting time for P1 actually 0. Starting time for P2 2. Starting time for P3 8. Now finish time for P1, actually 14. Finish time for P2 8. Finish time for P3 11. Direct from the chart we can write starting time as well as finish time. Now turnaround time. We know the turnaround time basically basically finished time minus arrival time. So finish time for P1 14, arrival time 0. So it is 14. For P2 8 minus 2, that is 6. For P3 11 minus 3, that is 8. So this is the turnaround time. Okay, and we can average it 14 plus 6 plus 8 by 3. Now waiting time. So waiting time, basically we know the formula for waiting time. Waiting time is equal to turnaround time minus burst time. So for P0, turnaround time 14, burst time 5. So it is 9. For P2, turnaround time 6, burst time 6. So this is 0. For P3, turnaround time 8, burst time 3. So this is 5. So this is the waiting time. And now response time. So basically response time, actually the formula for response time, actually fast response minus arrival time. So please write this formula. Response time is equal to fast response minus arrival time. So in case of P1, so first response actually at time 0 and second response actually at time 11. So this is called fast response. This is called fast response, and this is called second response for P1. So in case of response time, we have to consider the fast response minus arrival time. So fast response 0, arrival time also 0. So this is 0. In case of P2, we have only one response, that is at 2. So in case of P2, the first response 2, arrival time also 2. So this is 0. Right? And in case of P3, the first response actually 8, arrival time 3. So this is 5. So here see, so as P2 and P3 actually non-preemptive, so that's why waiting time and response time equal. But as P1 actually preemptive process here, P1, so here the waiting time and response time actually different. Okay, so this is the turnaround time, waiting time, and response time. And also we can calculate the throughput. So here the throughput will be number of process by total time. Throughput is equal to total number of process 3 and total time taken 14. So throughput should be 3 by 14. So this is all about preemptive priority algorithm. Now see, in this particular priority algorithm, we have a major problem here, and this problem is called starvation. So this problem is called starvation problem. So a major problem with priority algorithm is starvation or indefinite blocking. Actually, what is starvation? You know what is starvation. A process is ready to run but waiting for CPU indefinitely because of low priority, and this leads to starvation. High priority processes prevent a low priority process from ever getting the CPU. So this is actually starvation. And the solution of this technique actually called aging. So actually aging, it is the solution technique of starvation problem. So in this case we can consider the dynamic priority. So in case of aging, gradually increasing the priority of the process that wait in the ready queue for a long time. Suppose P1 a process whose priority 10. So this is actually very low priority 10, because high priority actually 1, lowest number highest priority. Okay, so obviously P1 must have to wait in ready queue for a long period of time. So obviously this is called starvation. So in case of aging, after a fixed interval of time, the priority value gradually increasing. So suppose after a time unit, it becomes 9. After sometimes it becomes 8, right? So this is called aging, and this method ensure that process with lower priority will eventually complete their execution. Okay, so this is actually aging. So the starvation problem exists in priority algorithm, and using aging concept we can solve the starvation problem in priority algorithm. Okay, so this is the all about priority scheduling algorithm, non-preemptive priority and preemptive priority. Okay, so in our next lecture we have to discuss the another scheduling algorithm. This is round robin algorithm, and round robin algorithm actually the pure preemptive algorithm. Okay, actually we already seen FCFS, a pure non-preemptive algorithm, but SJF we have non-preemptive and preemptive mode. And also in case of priority algorithm, here we have non-preemptive and preemptive mode. And now we have another algorithm, round robin algorithm. This is actually pure preemptive algorithm. So in our next lecture, we will discuss about this round robin algorithm. So now, thank you for watching. See you in the next lecture. Thank you once again.